Good evening. Good evening. This is Engineer Suraj Singh speaking from Bharat, India, and addressing this talk to all people around the world, professional people and otherwise. This talk is this talk is meant for drawings related to formula demonstration. I have given so far I have given so far certain Excel sheets or worksheets that relate to formula derivation or formula composition on worksheet. You remember I have given you many times talks about that sheet, which I cannot show you here because I am now sharing screen with drawing software. Purpose of this is to just give information about as we change something in editable cell on that spreadsheet where I said this is strip width. If we change that by whatever percentage, say it is 10 given there 10 meters, I want to say 12 meters, I want that means 20% increase, or I want to change by 10%, or I want to say reduce by 10%, like that means all calculation results will change. That is variable. We call it variable, and all results are not variable. Those results are automatically changed depending upon variable. Now, because those formations have been based on drawings, actual drawings, that I'm going to show you how these drawings work. Let me first of all give you certain idea. For example, say this is, let me first delete this because I have tried myself first. Let me say delete this. I'm copying this. I'm copying this. This you can say this triangle here. I'm just copying it here for your reference. And I give dimension to this. I'm just giving dimension to this one for purpose of showing how it works. Let us see this dimension is here. It's little small. Let me give big one. And it is, I'm giving a big one, and that is say it is 10. Just like this, I would say DLI. This is you can say this is dimension of this, and I say DAL. This is the dimension aligned, and this is this one, or this is this one, whatever you can say. This is this one, right? Now, because this is dimension here, whatever it is, I want to change it, say by 10%. You note it, what it is. This is dimension whatever here. I want to change it, say by 10%. I say 1.1 factor I apply. So you see this has changed. You see how it happens. If you reverse, it's 5.9. Now, if you change it, is this one. And if you say further 10%, I say, if this one I change to further 10%, I say again 1.1, it changes. All dimensions change, Again you say I change again, and we say okay, I again apply say 25% here, now 1.25, and this change. This changes in dimensions is being used for purpose of calculation. You got my point. Let me go back and see how it comes back. It comes down, you see, it comes down automatically because we are using scale factor. Now, again, I'll show you, again, I'll show this is like here, you can see, I'll show you this, we can see here, or you can say something like that. Dimension, I need dimension for you. So I go here, I put it here. Let us say already dimensions are there because I put them. Some dimensions are there. You can see, and also internal dimensions must be placed in somewhere. Let us say this B L I. I say, let us say this is here. You can say here it is. Oh, it's too big, so let me say small scale. So this is dim scale, and this is scale I say 3, I take 3, let us just for information. Now DLI, it is I take here, that is whatever dimension is here, and I take some dimension here, let us say here, and I can say DAL. Already there are dimensions of DL, but let's take again there. Now what to do? I want to increase all these by a factor of 10%. So we'll say scale all. We'll say okay, I want 1.1 here. So you can see complete change, right? You say again I want repeat scale, and I say okay, again change it, and you can say I already selected, okay, base point is here, and I say okay, again I say 10%, so it changes. You got this complete change, and if you see reverse this, it comes back, so it goes back. All dimensions are affected. You can see all dimensions are affected. This phenomenon of means whatever you change there in Excel or in spreadsheet, same percentage if you have a diagram or drawing you can make here. Now let us see something else here. Let us see, because I cannot go for everyone. Let's say this octagon here. Let me see this bigger one. Let me first delete this dimensions, because this I want to show them little bigger so that you can see that. Alright, I say I'll show you that one right now. I say dim scale. Let me try first how it works. DLI is seeing bigger ones, fine. It's not getting bigger in this. Dim scale, and I use dim scale here. Dim scale, and I'm using 3. Let me say 6. So DLI. You see, yeah, you can see DLI is here. So it's little wider, you can see, or we can, no problem. Maybe you can't see that. So let us see, let's change this again. Because sketch is bigger one, so dim scale 10, I say 10, okay. And I say DLI. Let us see DLI is, this here, okay, you can see it now. And you can also see here, let us see, this is how much. And I'm just showing 2 or 1 and not more than that. And I say DL, and this is here, and this is, you can say, also similar for this. Now let us see how it works. Even angle is there, angle shall remain same, SC, and we can say here, and let's say 10%, let's say 10%, 1.1, you can say it changes. I reverse it, you see it's again change. You see angle is not changing, just note it. Angle is 162 here, 72 here, it's not changing, you see angle is same. There's no change in angle, you can see arrow is changing but angle is not changing, and these dimensions all are changing. You can see very well. See 52 for example here, stop, and you see now 57, and again we say okay, I repeat this, redo. I do, let's say I move this way, and let me move this side so that it will not clash with other diagram, other drawing. So I keep it here, and let me apply again SC, and I say okay, I make it like this. I make it 1.2, 1.5%, let's say 1.5%, 1.5 increase. So each down, you can see dimensions change immensely. You can see it is now it's 32 point. Now I can say, let me show it again. It's undo this, and it comes as okay. Now you say I apply this on this. SC is 30%. Let us say 30%. So here's 1.3. You can see all changes there. Angles are same. We undo that. Now I say we undo this fully, and we go back to its original dimension. Now I say I reduce this. So I 15% I want to reduce this. So I say 0.85. Anywhere you can put it 0.85. 0.85. So it is reduced, right? You see, again I say I want to reduce further. So you can say it's that. You can say here and it is reduced further. So it goes down, but angle still remains there. This is property of this, and we have to understand this point. It applies everywhere. Whatever changes you make in that dimension of 10, it will affect everywhere. I'm just showing you now. I can say parallelogram, for example. Let us say how this works. DLI. You can see this parallelogram is here, and you can see and height of this is here. This is height will be here, and you can see. Then okay, DL we take DAL. We take here DL. And this is here, and let's say the diagonal DAL here, and we'll say okay, this is down. Just like or keep somewhere here. Now I increase this. I will increase this by 20%. Let us say increase this by 20%. 20%, 1.2. So you see all changes there. And let us repeat it again, another one, same way, and this is here. So this is increase one. You can see that. Now reduce it. You can say it goes down and down. So this is what is important. We are using this part of this one. I just examples I'm giving you. Now I'll go to another file here, and that's this one. Let us say I will use this the same thing for something else here. Let us say V, for example, V. You can see dimensions are there, but I'm keeping dimensions, but I use A there in our calculations, A. Though we know A, but how to do it now? Let us say SC, we increase it by 10%, let us say. You know dimensions, I'll make another one. Let me see. I'll copy this first, and then so that you can compare to. And let me say copy, and this goes to. Let me keep it here, somewhere here, for your reference. Okay. Now I make changes to this one. This is a scale. You can compare the other one. You can see this. I make it 20% wider. 20%. You can see this 10 has gone to. You can see that here. 10 has gone to 12. 75.62 has gone to 90.75. 89.4 has gone to 107. And same thing, 96, it is for 80 before. 90 has gone to 108. And this 12.6 is 14.83. So it's like that. Okay, we give another boost to this. SC, we give, or we can let's first do let's say SC. Now reduce by 20%. Let us say it's 0.8. So let us say how much. So you can say, because percentage wise it's not exactly, so it's come to that one. Or we reduce, you can say, all right. Now I reduce this dimension say by 50%. I reduce this dimension by 50%. You'll see size changes and everything changes, and it is 0.5. You see that? I dimension reduced by 50%, original one, not this one, which was increased. Let's say it was 108. So 108, and this was previously. So I do the 1054, 6.7. See again, 108 has gone 54, and this 12 should be 6. So let us do that. So it's a 6. You can see that everything changes there. That's what's beauty of this one. So I just remove this and go to some other where. Just for your explanation, there is no X. I take care of X here. Let's just see how it changes. The dimensions are there, and we copy this first of all. So that I copy this, and we keep it here just for a comparison purpose. And we say, okay, I will scale it. I scale it, and we say we increase by 25%. We increase by 21.25. 1.25. It is so you see this. Now you can compare it how it is. You can see here, this was 7.53 has gone to 9.41, 6.7. This way, 90 has become 112.5. Because you cannot see this, I'll change 9A from here, move 9A from here, so you can just see this correctly. So this is 1912.5, 62.6, 55.4, 55.17, 68.97, and angle is same. Angle is not changing. So you can say in parallel to existing one, it has gone down. Or you say I'll do it first. Another one. I make another scale out of this. Say by 10%. Let us say by 10%, 1.1. So you see it's gone again. Size has increased and gone again. Or undo this, you come back, and if you undo that, it comes again, goes, and then you can say it comes back. So it starts. So I erase this because purpose is just to tell you, because I don't even remember. Now let us see curve one. How curve works here. Curve is here, S, for example, S we are taking. This is dimension. I put one dimension is here. I put other dimension as well. This is also true. You can see this is, for example, 27.5, and this is our, this is our, you can say, basic dimension, that is stiffy, in which we are converting all this, and you can see this, the radii, and we can just put here also, you can say from here to here, we can put like this. So this is also, no, it exactly should be 80, some error in selecting. So you can say realign. It is, from here to here, it should be exactly, yeah, it's 80 now. It's 80, and other one is here is, if you take from here, take from here, it should be, I think, 50. Should be 50. So it's 50. Now let us see how it works. SC is here, and this is here. It is gone. SC here, and let us increase it by 25. 25%. So it is 1.25%. You see that what happened? 80 has gone to 100, and 50, 30. This 34 was here. This one was 34. This has gone 62. 50 has gone to 62.5. Sorry, and this was something before 34.3 as well. Now we'll undo this and go back to where we were. So this is there. Let's come back to original position. Now what to do with this? I'll reduce this. Let us reduce by 10%. We reduce by 10%. That's 0.9. You can say 0.9. You see that? So 80 is now 72, and 50 is now 24, 45. And you can say 10 has 9, and radii have changed, 20, 25, 15, 75 have changed. If you see original one, it was different, it was 10, you see, undo, and this undo, so this is come original. So now it is original one. You can see radii 22.5, 75.5, and if I just increase this again, let's see, let us increase by 50%. We can see what happens. You see 1.5. You can see 75 and 120. Dimensions have changed. All circular radius all have changed, and this 10 has been 15. This means if you take dimensions from this as we used in our calculations, I first let me undo this because I want to see the original one for clarity. So it has come back. Okay. Now, so if you take dimension from here and then convert them, for example, now we take this one, DLI. We take this one here. You can see this is here 10, and this is here. You can say something like 55, because 25 is 80 is total, and we we just try this. Let us see in between how much. In between is this is 30. Now let us try. Let us say increase by 50 or 25%. Let us say increase by 25%. 1.25. 1.25. You see 68.75, 37.5, 12.5. Even this area has changed. We undo that. You can see well now what changed, and if we undo that, it becomes like this. You can see. We come back to let's say one now, or we undo that, and we undo that. We see changing again and again, and redo. Redo. You can say so. It's like that. So, and we come back again to the same position as a result. And it's that one. So it's that one now. We have seen in various shades. Now we'll take case of 3. 3 or 2 even, we can take case of 3 or 1, whatever you want. Let us take this case here. 2 is available. Let us try 2. And actually this is 2, but there's a framing here which we have to remove, but no problem. We'll take as per now. All dimensions are up to dimensions there. So let us increase by 10%. You will see 50 has to go somewhere, and you can say if you increase by 10%, 50 has become 55, 80 has become 88, 10 has become 11. You see all these dimensions have been affected accordingly, and this radii and all things affected. Let us see horizontal normal. 25 it was, see 25, 20 and 15 is going to 27.5, something like that. And again we repeat and we say okay, we do it again. We can say let's see again by 30%. Let us say by 30% further, it's further by 30%. So 1.3 and it's this, you can see 14.3 and this is 114 something, and like that. So you see 56 angle is same, and these all changes, these dimension change. So we come back to original position, and we can say we come back to original position and see how it works. So we have come back. Now this is what I'll show you more in this. That's a simple one. We take it. It's also there. Let us try SC, and I'm just trying to show you many cases because let's say it is 0.7, 70%, 0.7. So it goes down. You see, it goes down to 21 because 70% of 10 is this one, and this even everything has changed except it. So undo that. You see, it's come back. So this means if you relate our calculation to exact time, means whatever happens here, that shall also show that. Show that one. Now we go to, I think 3. Let us say dimensions are not actually okay. We use U and let's say Z here, where dimensions are shown. I think 10 is shown there. Yes, 10 is shown there. So SC we take here and we say okay, we don't care, and we say by increase by 50%, 1.5. You can see. So 10 has become 15. So 10 has become 15, and this you can say that 75, 50, 75, and this has become 70 to something. That's what it is saying. All dimensions are affected accordingly. So this is what. And now we'll go to let's say I don't want to make a very long video for this, only 3-4 minutes. Okay, I'll say okay, we go to some other file. I think as we have to let me go 3 also somewhere it is. Let me see where it is. 3. I say what's here. Let's okay 3. Let us say this is here. Okay, because now we start here. 3 is there, of course. Let us see 2 have done. 3 we see here 3, and you can say 3 here. Dimensions we are not given here. Let us try the dimensions. Scaling is actually, radius is there. Let us try if you can do it live. You can say okay, and let us say here. So we have required dimensions. Now let us see what we should do. Now you know this all. Of course, the radii is very small. Let us see if we can make a larger one so that you can see well. Radii, if you can see angular, no angular. This is radius, so it's a little bigger. So I put that one here as well as here, and of course here. It's like that. So that is just for we are trying only. Angle you can see, and you can see, let's increase by 20%. Let's increase by 20%. I think you can put in see 1.2, and you can see it's become 96 and 60 is 30, 34, 18, and also smaller one you can see they have also changed, so we can see here directly. You see everything has changed, and these angles, these dimensions also change. How we can see? Let me see. Undo this, and undo this, because we go to original position of it. Now we see how much is that. See how much is that? You will note something here. Let us see 7.53 and see how it works there. And I think I missed some command. Hold on, I missed some command. Let us do it again. I think SC by, let's say 20%, no problem. Let's say 20%. So 1.2. You can see this. You can see all this original one has gone. Original one has gone here. All dimensions have changed here. This is changed. Everything is changed. Radii have this, and 60. All this is gone. So we just undo this. We will go original position. Now we take simple one without something. We have seen 2, we have seen 3. I will also show you means where, how far. Let's say 5 here. 5 here. You can see 5 here. And you can see dimensions here accurately. We will try to see reduce by this 15 here, and you note this all here, and we have this dimensions will be 10. We are not written. I'll just make it nothing here. DAL, and you can see this is 10 here. Let's see. Not this one, sorry, not this one. This one here. This is, let's say here. I'll go here. Let's, oh my God. DAL. This is here. Yeah, this is 10 here. And we can say, let us say some diagonal here we write for this is diagonal here. This is 14.26. Now we try here to change it, to just to change it. Okay. Let's see. And we go there. 80 will not change, 5 will not change, but you see we have 25%, or we say reduction, 75.75. In reduction, you can see that everything is reduced. The radii are reduced. This is 10.67. And this 10 has gone to 7.5, and you can see here this is again we come back, no problem. Undo this, previous one, and it's come back. It's come back. If you undo for this dimension will go away. You should put in there. That will go away. This is gone. Previous dimension is gone. Now we take case of let us say 7. Okay, 7. Let us say case of 7, and you know dimensions here. A is 10. 10 is not written. Let us say DLI. Here 10 as well there. You can say 10 here, and you can say something is here 20 here maybe. Because after this you can say that, and here we can say 50. It's there 50. So this 50 here, and already there. Let's try now. Let's see. Let us increase by 10%. 20%, say 20%. No, 1.2 it should be 1.2. 1.2. You see what happened. You can see this is now 12. 20% is 12. 10 goes to 12. 50 goes to 60. and this 24. Now so 2024, and it is, everything has accordingly changed, so we just undo that. So that comes back to original position. You can see it comes to original position. Now we go to 8, because this is a complicated one. We have to understand this just to show more and more it's better. And 10 is there, 10.14 is there, it should not be 10.4. This error value of this is not 10.14. This is something wrong. It should be 10 here, it is 10, so it should be 10. You can say here, and you can perpendicular here, so this is 10. So this is 10, this is the here. So all you can see here, and we say we increase it by 50%, let us say. See, all this shall increase. Let us say increase by 50%. So it is 1.5 now, 1.5 now. So this is increased. See, these are all increased by 50%, and 12, I think 12, 20%, not 50%. I do it again. I thought it's the. Let me do it again, and let us see how it works. 50%. I see, and this is 50% change. 1.5, right? 1.5 now, okay. So it is 15 now, and all has changed. You can see this. 15 is here, and this all changed. All has changed. All has changed, but angles are same. Angles have not changed. You can see that 96 angle is still there. 96 is still there. 96. And I can see, okay, we bring it back position, previous position. Previous position has come. Now it will come because undo. So this is that. Okay. Now let us see 9. It's a very complicated one. You have to see that. It's a little complicated one, but it's no problem. We can read that what it is, so that we can see what's radius here and what are these dimensions, which are trapezoidal here and one angle 50 here, and we can see how it works. We increase by where's 10? 10 is not shown here. We show 10 also before using command. We can say DAL, and we can say here, let us say first of all here, and let us say it is 10, and then we can say okay, it's for every year, but no problem. The clarity I take on curve also here. Is that 150 is here, just note it. Now I see we'll increase it by 30%, let us say 30%, increase by 30%. 1.3. See that? 30, you see 150 is same, angle is no change. No angle is changed, 13 is here, and radii have changed. Radii have changed. This was 55.55 has changed. You can see this all has changed. Everything has changed, and this will reflect in our X. There will reflect. Let us now undo this. It has come, 8 has come, and now. So we have to see now 9. Now 0 is also means the same thing. We just try, no problem. Once we can try here also. 50% decrease here. Let us try 50% decrease rather than increase. Let us practice 50% decrease in this case. So we'll say 1 is 0.5 only. You see, it has become 5 rather than 10, and this is now 12.5 and 25, and this is 30 in place of 30, 15. And let's go back and see. So we just come back to same position. Now let's go to other file, see how it works. Let's see this here, let us see how this works. For example, 6 here, full ring, 6 here, maybe yes, the 6 how it works. You see note positions here. Let me put TLI, which is our spatial consideration, TAL, which is our root actually. That's our control point. So let's do that. Go to this is 10 here, and you see these dimensions here, and we 10 here also, just for no, some error in that. So let us say this is perpendicular, and the perpendicular here, so this is 10, and here also it is 10. B L I is also 10. So we can see this way and this way. So this is 10. No, this is 10. Here 15 and all that, you can see angle is here, you can see 53, and this dimension now I'll shoot it, and let us reduce it into or let's increase by 50%. Increase it by 50%. Okay, keep adding here 50%. 1.5, 1.5, how much I put? You can't see this. So it's 50% increase. You see 15 here. Angle is same, no change in angle, but the dimension have changed, This dimension has changed, radii have changed, everything has changed. This is what it is. So let's go back and decrease this. The same value as it was before. So you can say it comes to 55 it was 0.55, so it is 10. Let's come back to original position. So now we can say, let us try this 8, for example. Let's try. I'm just giving some cases, not all cases. I want to justify, means if you use these drawings, sketches, exact sketches, and incorporate this in that, you will find whatever dimensions we take from here and convert into that divider, or you can say step width. In that term of just like we say 4a, 3a, 4.5a, you will find that now in this 10 is not here, so we add 10 here. Just for understanding, means it is 10 here. You can say 10 here, and now we can say from here to here, it's it's 80. It's actually very small. Let me do it again because you can't see small one. So the scale that we use for changing the scale, so it is 0.5, so I keep it 3. Okay, fine, then it is now DLI. It is now DLI, and let us see how much. It's 10 here, let us say, and it is, you can see here it is, as you can see this is here, here, and here it is, you can say 40, and here it is 50, and here it is in somewhere, I can say, let us say some diagonal here, let us say some diagonal here, like, but this diagonal will come different way, so let's say this vertical 25, diagonal maybe DL, so it's that one, and we'll put this here, let us see how much it is. It is 32.7. Now I increase by 50%. I increase by 50% this one. 50% increase is there, and you can see this. Let's say 0.5, 1.5. You can see that. Now 60 is 30, 50 has been 75, 80 by 120, and this diagonal 37.5 from 30. This is all change. You can see 10. Where is 10? I put 10 or no? I think I didn't put that, right? I missed that one. Once again, go back. So if you go, so it's okay, right? Okay, that's okay. All right, I put that back. Now let us see 10. Where is 10? I will put 10. Because got lost, yeah, lost. So it's here. This is 10. Let us see somewhere. Oh, it was there. I didn't see it was there actually. It is there, already there. I didn't notice that one. Again, I do it. I see 50% increase. So we are saying increase 50%. So let us say 1.5. And so 10 has become 15. If you just move that 7. So I could not see because of this 7 here. So 15 it is, and 50 is 75, and this is this is you can say. We start going. Oh yes, 120 is some another figure, but it's 120. So what is said is that come back, and see how it is. Now, I think every sketch is same, so I don't want to check all sketches. Some only selected one I want to check here. So 9 we have done already. We don't do again. Now we go to next file, and that's here. I think we're done this or no? Yes, we're done. I think. We've done this, which we want to be. We've done this as well. We've done this as well. And this is here. Now, let's see. Okay. Then I think, okay, this is right now. This will come back here again. I think there may be more files. I think, just check. Okay, let us take these square figures. Square figures are also important one. For example, let us say x. I moved on, I copied it, I moved on because here in the core level. Otherwise, we'll say here, and this is here. Let us say, and now we need to say 10 is there. No, that's our chances. 10 is not there, so we'll put 10 first. Let us say 10 is here, and it's here. Then we have some other dimension as well. Let us say this is 30 here, and let us say DAL here, just for saying, and we will say this, and we'll increase, and we'll say, enter here now. Oh my god, what's not entering here? Okay, no problem. And then let us now try increasing 50%. Increasing 50%. Let's say 1.5. See that? 10 has gone to 15. 10 has gone to 15. And this is also, I can't see this. 135, I think. Maybe 90 it was original. It's 120. And all this is 7.5 is 45, 30. So this has done. So I go back to original position so that we know what exactly it was. It was this 90 from 135. So it's okay. So I delete this also from here because I want to just add a sketch to original file. So I just erase, now. Y is also important. Let us see why. Y is also very complicated down here. I think it is done separately as well. I don't exactly remember. It is here. Y is which one is that? It is 6 and that, and let's say here. It's here. We can say it's here. It's not in this file, so let us see why is here, or maybe use this. No problem. I copy this first so that it should not encroach other. Let us see how it is. Now let us see here like this. Now you see dimensions here. 10 is written, yes. 10 is not written, yes, written here. It's 11.8 here, and I 10 here also. Here also in vertical member. This is here. Now let us try our best. Let us say 50%. Let us say 8 now 100% English. Let us say how it goes. Let us see. So it is now 1.5. So this is 2, right? This is 2. You can see this. It's become 20. It's become 20. It's become 100. 50 has gone to 100. 20, and everything has changed. You can see that. Yeah, also 20 here. So everything is gone changed. So we just undo that. We back to 20, 10. So it's there. Now, everything can be done that way. That's a very important point. We have to learn this and use it like that. I did not take a whole file. Let me see if I'll close some of these files and see other one because I closed this file and let us the kernel is not available. We can say close this file, and now we don't want to see changes. Alright, now I think there's some. Let's see this. I show you this. I don't remember. Let's see. Let's try on this. Is a very complicated one. Let's try this. No problem. Let's say whatever dimension is there, just note a dimension. Though even if you don't know, this is all the same as is here. 22.31. So this is same. So we can try here and compare. Then that's not a problem. We see here. we see SC, and we select this, and we say okay, increase by 40%, let us say 1.4. See, now we compare these two. 22.31, 31 point is. This dimension is 10.069, this is 14 point is. Angle is same, angle is not zero, angle is same. This 90 is 90. And this is 11 point here, and this was, you can say, this was not given in that, so it's okay. This is 14, and here 10. 27 something, here 39. This is 20, 35 here, 20 point something, 35 something, 11 point this, and this, you can see there's a difference. So this clearly says, means what is done is done. What is done is done. So this one is done is done. And now, same way we come to various other here. Let us see case of rhombus. Dimension not there. So let us see this. We'll close this file. Close. Save nothing, and this goes away. So we close this file as well. It goes nothing. We do nothing here. This goes away. Nothing here. So this is left, and this is left. This is left, and this is left. And we can close this also. What we have seen all in this, so we close this also here. So this is closed here, and this is closed. Say no saving. Now we select other files to see something else. Let's say geometry here, the same. This is this, and this is this, and this is this. Geometry one. Alright, let us see something. 2 is there. Okay, we'll take this file with us and see. You can see this is also a reasonable file. You can see here dimensions are the dimensions. Many dimensions are here, and also I didn't put dimensions here. Let us see. Well, no problem. There are some dimensions here. This shaft is fine or something. I think you can see these dimensions, right? And what else is there? Is the width is there, and all is there. So let's move this. Copy this because it will encroach on another one. Let us copy this, and or we can move this. We can move this. Means why copy this first? Let's move this. Move this and keep it. Bring it somewhere there. So it's far away from there. It cannot be affected. So we can see now. All these you can see H and H150 like this, and all dimensions you can see. Many dimensions are there. We now apply 50% increase. Let's see here, 50% increase in there. Let's say 50% increase, 1.5. You see 300 is going to 450, and all dimensions are gone. 450 here because of the little triangle, and all dimensions are increased. The angle is same, and we can see this. And if we just undo that, see it's gone. Some 300 you can see. And redo it, you see that. Redo it, undo it, you can see that. Redo it, you can see that. You see, this is going like that. And then let us see this. These one, okay, let us see this first of all. Let us see this. Let's try the alloy. And this is here. And sorry, this is here. And this is here. And let us see from this here to this here. Let us try this. We increase by 25%, something like that. We increase something like that by 20%. Let us say 20% only. So we can just get something. So 50 has gone to 60, is gone to 108, is going to 12. This has changed drastically according to that. You can see that. So we come back. We keep like this. Now we will see whole diagram here. We'll see this guy, how it changes. Let us see, just to see. We see some dimensions only we give here. And see how it works. Let us see this is 10. few only we give, and we can see whether it's okay or not. Let us say here is 40, and let us say here is 10 again, and let us see how this works. Only with these three we can see how it is. Let's reduce it by 50, reduce by 50%. We say 0.5. You see that, 0.5 is here. All these changes, this is become, you can say all have changed and dimensions are there. We put dimensions here, we put here, and we put somewhere here. So that is this one. This one is here we put, and we put somewhere one also. It is gone. Yeah, it's there. It's here, and let us say undo that. And because it is 50% now showing that. So you can see this one 10. Now it's come back to horizontal. So let us use this and see how it goes. Okay, there's another one here. Dimension is here, dimension is here. And let us put more dimension so that it is clear. I'm just trying to give many cases here so that you may understand how we work in this. 90, and this is here. Also 90 probably. And this is here, you can say, if I give it, if I say DL here, and we say here, right, okay, this is 300, and also you can say this is if you take from here, a line we take from here to here, 100, and of course here to here. You can say from here to here, it is 7. Now let us apply 10%, or we can say some whatever. Let's say apply here 20% reduction, 20% reduction. This is 0.8. You can see that it's gone like this. It's just parallel motion when dimensions are changed. Right? Let's say this. You can say once again go back. Let's come back to 300. Let's come back to that. Let's come to 90, and if you see redo, see go back, redo, see 240, redo, like that. So you can say so we can say that I think the video is stopped probably. I don't know what's the event log. Event log says that not receiving regular signals, it's not receiving signals, not receiving signals. It's not receiving signals. So what's happening? What's this? I don't know. It's gone. What is that? It's gone. It's coming back. What's that? I don't know. What the reason behind this? Let us see. My purpose is to just tell you what's happened actually here. How to use this? How to use other one? How to use these files? And let us know. I think you understand what I'm saying is we can, if we change there in variables, strip width, it will affect whole, and if it affects whole means it will give right results. Even angular dimensions are, radii are changing, everything is changing. So we can say we can manage that one. I think you understand any part what I mean to say. 724, so I have to and you can say also this. I just wanted to show you how we can use drawings. If drawings we have means and we note exact dimensions and convert them to our variable strip width, you will get complete connections automatically of change, because whatever is shown here is also noted there. So whatever results that worksheet shows of calculations or area or parameter or circumference or volume, or you can say surface areas, or whatever that shows, it will be exact according to if drawing is right. If you write your show drawing is right, it will work there, and your noting is right. There is no link here. that cell cannot be linked to this triangle. That's not easy, very difficult. I actually don't know that one. So with this, I can say, understand what I mean is that you understand that point. So I'll now take your leave before it's now time. It's around 55 minutes. My only purpose of this demonstration is that yesterday you were little not clear, but now when I tried on drawing, everything is changing. It's accepting, it's accepting. It's accepting all, and I've shown you many drawings, and also there are so many drawings. I cannot say which one means. You can say, for example, this is already we have discussed. This we have discussed. Let us see which one this is. This okay. This is 9 and 2. But taken, we have already discussed this. All is same, but I checked this and it's just, let us try this SC. It says that it is increased by 50% here. Let's say 1.5 here. So it's that one. This changes. 55 goes to 83, 91 goes to it changes. That's all purpose here. And you can say that we have to be now clear about what we did. See, what we do in engineering, or what we do in profession, or what we do otherwise in mathematics language or some other calculations. We should be sure of that, because we have many softwares these days. The spreadsheet is there, and drawing software. You may not be knowing drawing, but if you know, if somebody gives you, you can use that. And that's the only purpose I tried to show you about this, which is a very important one. And I have not done more work on that, but this is first verifiable work that I see. We have to validate our worksheet, and we worked on this. It's not easy. Nobody would give you 9 figure like this and say we worked out this area and that area, but that is, you can say, a new kind of beginning. We can find out area of, even for a key, you can say, or something, anything, big one, small one, and this can be enlarged automatically. When I say 10-20% means, so there's a 10 already in that. You want to write 12, so this is 20%. You say, no, I want to reduce, so you can write 8, or you can write 5, whatever you think is right. And automatically that would come in the right position, right way. That's the whole purpose of this. I think you got my point, and that point is actually to communicate to you people that we can use these softwares to best of our caliber, and that's important point. I think you got my point clear. It means, and also URL given on this video. URLs are there. You can see past videos of Excel as well as this fee only, and you can do whatever you wish to do. So I think I should now take your leave in 1 or 2 minutes. Give a message to you that you learn it, practice it. Don't make complicated formula immediately. Try to do simple, and if you can do that, that's okay, fine, it will work. Don't make it too difficult. Don't make it too difficult. That's it's difficult if you understand Excel or Lotus 1 to 3. You understand how these cells work, how these cells can be linked, how this can be used for a complicated formula. You can do something. If you say, no, I just want to do what is given in Excel book or where Lotus book, I don't think you will do something. It's your own concept, how you can use these cells for composition of formula, or you can say using plus minus, multiplication, division, square root, or exponent, or trigonometrical function, whatever way a combination of various mathematical theorems. For example, triangular area as seen